Hey guys, today we're going to talk about lesson 2-1, which is going to be converting fractions to decimals decimals to fractions and fractions to decimals. My voice is a little scratchy, so I apologize for that. Converting decimals to fractions. And fractions to decimals. So one of the things that we're going to be covering in chapter 2 is going back and forth, being very fluid with how something's a fraction, a decimal, percent, and back and forth. So that's going to be our eventual, what we're going to cover. And today's date is going to be 11, 12, 13? 18. Yep, 11:13. Okay, so here we go. We're going to talk about definition, which is always a good idea to make a flashcard of. And then we're going to talk about how to go from decimals to fractions and then fractions to decimals, and give you some hints and tips, and then we'll practice. So let's start with our first word, rational number. Rational number. Now, what you might notice is that the first 5 letters of a rational spell the word ratio, which we've just been talking about in chapter 1, which is the comparison of 2 numbers using division. So we're going to say that the definition of a rational number is any number that can be written as a fraction. Now, you might say, well, how does that have to do with that? Remember, a ratio is a fancy way of saying fraction, okay? So, we can take any whole number, any fraction, any decimal, and we can rewrite it as a plain old fraction, okay? So this goes for whole numbers, fractions. Now, when I talk about fractions, I'm talking about proper fractions, improper fractions, and mixed numbers are all included under fractions, and decimals. So pretty much every number that you've studied is considered a rational number. Now, you will study about irrational numbers. You actually know one of them already. Pi is irrational. So anyway, let's go ahead and get to our processes. Let's talk about how do I go from a decimal to a fraction. Decimal to a fraction. So basically, all you need to do in this case is to read the value using place value labels. Because those labels are going to tell you what the denominator is. Okay, so I'm going to give you an example. We have 0.45, but that's not how we read it with place value. If I read it with place value, I'm going to read it as, 40. Nope, that's not right. 45. Oh, where's that X come from? 5/100ths. So what that tells us to do is we're going to take the 45, and that becomes our numerator, and our denominator is the place value that we just read. So we have over 100. Now, as we've talked about before, you must simplify. Cannot leave a fraction that has not been reduced, and these both have a 5 in common, and our final answer is going to be 9 over 20, or 9/20ths. Okay? So that's how we change a decimal to a fraction. We just read it using the place value labels. Okay? Now, the other way to think about it, too, and I'll just point this out. Notice that here there was 2 digits after the decimal point. Notice you have 2 zeros. Oops. That is not a coinky-dink. That's supposed to be the case. Okay? So keep that in mind as kind of a short way of thinking about it. Next, let's go the other direction. Let's go from a fraction to a decimal. Okay? So we have 2 methods. The first method is going to be the equivalent fractions. And what we're going to do is take our original fraction, let's say we have 2/5, and we're going to turn it into a fraction that has some decimal place value in the denominator. So in other words, tenths, hundreds, thousands, or so forth. So I'm going to write this underneath, and then we'll finish the problem. So we're going to scale up or scale back the denominator. So these are the one we're focusing on, to become 10, 100, or 1,000. And so what we're going to do is look for the smallest number that 5 can go into. That's either a 10, 100, or 1,000. So if you notice, we can get 5 to become 10 by scaling up by 2. So we're going to multiply by 2, top and bottom. So that gives me 4, 10. So what we say is if this is 4/10, our answer is going to be 4/10, written as a decimal, so 4 in the tenths column. So that's one way to do it. Now, this strategy only works if our denominator can go into 10, 100, or 1,000. If it can't, then we're going to have to come up with another strategy. And that strategy is going to be divide. Yes, our good old friend division. So remember how this looks? We have a numerator over a denominator. And so what we're going to do is to take that numerator and we're going to divide it by the denominator. So I'm going to abbreviate denom. Now, probably back when we were working with the decimals, the most common mistake was to switch the place of the numerator and the denominator. But we got to remember, we're going to take the numerator divided by the denominator. That's exactly how you read a fraction. Okay? This strategy, what's great about it, it always works. So, strategy 1, equivalent fractions, only works if my denominator can go evenly into 10, 100, or 1,000, or so on. I can always divide. Okay? So, let's go ahead and practice. Okay, this looks totally awkward, but this is the best I could get this. Every time I try to make it straight, it wanted to flip over backwards. So just roll with the punches, I say. So we've got this chart, and it says write each decimal as a fraction in simplest form. So, oh, I notice I did something wrong. Okay. I'm going to have to go back and fix that. So these numbers are actually supposed to correspond to the numbers in the chart, which I'll be writing in a minute, which now changes all these numbers. So hopefully you will get the fixed one. So I'm going to kind of extend this chart. We can go thousands, hundreds, tens, ones, and then we go tenths, hundredths, and thousands. Now, of course, this is going to go right here. Boom. 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 Okay, so the first number looks like this. Okay, remember here is the decimal point, so there'd be a decimal point right there. So if you notice, there's only a number and it's in the tenths column. So then I would say this is 8 tenths, and I would simplify by a factor of 2 since they're both even, and that gives me 4 fifths, and I cannot simplify that anymore. That's as simple as the problem is. Next one, we're going to have 0, you know what, let's go darker. 0.28, but the 8 is in the hundredths column, so we're going to have 28 hundredths. So notice, when I read it, I don't say point, right? So there's no decimal point in the numerator. All right, let's see, 28 and 100, they both have a 4 in common, and that's going to give me 7 over 25, or 7/25. Okay, next one, again, we're going to have 0.125, but if I read that, I'm going to say 125,000. So I'm always reading the last digit. Okay, the last digit's place value column is the one I read. So I have 125 thousandths. Now this guy has for sure 25 in common, top and bottom. And that's going to give me a 5 over a 40, because 25 goes into 100 4 times with a leftover 0. But I did notice 5 can go into both of those. So it gives me 1/8. So 1/8 is the same as 125 thousandths. Now we have a bit of a word problem. And it says here, it takes approximately 4.65 quarts of milk to make a pound of cheese. Express this amount as a mixed number in simplest form. So at this time, we actually have a whole number, 4, and then we have our decimal point, 6, 5. So again, this lands in the hundredths column. So we have a 4, so we still have a whole number part, and it's only the 65 that goes over the 100. This is the easiest way to write this. And I notice that they're both divisible by 5. So we still have the 4 out in front. And 5 goes into 65 13 times. And 5 goes into 100 20 times. So this one, because it's a word problem, we're going to have to add a label to this. So 465, or 4 and 13/20 quarts of milk. Okay. Now we're going to go the other direction, and I'm going to talk to you about 2 different ways of doing this problem. So because my numbers are smaller on the first one, I'm going to be lazy, and I'm going to use division on this one. So remember how it works. This is your numerator, or num as we like to abbreviate it. This is your denominator, denom as we like to abbreviate it. And we're going to divide the denom into the numerator. So the numerator is being divided by the denominator. So we're going to go ahead and put in a decimal point since 5 goes into 3 0 times. And then that decimal point up in the quotient allows me to bring in a 0 in my dividend, and 5 goes into 36 times evenly with no remainder. So we get the answer is 6/10. Okay? Now, this one, you might think, oh gosh, I'm going to have to do division on this one. However, if you think about it, there is a number you can multiply 250 by to become a 10, 100, or 1,000. Could it become 10? No. Could it become 100? No. Ooh, but it could become 1,000. So what is that sneaky number? Well, that sneaky number is a 4. So I'm going to multiply top and bottom by 4. Actually, let's do it this way. I like it when we do our boop, boop, times 4, times 4. And then we get in our denominator, 250 times 4 is 1,000. And in our numerator, we get 102 divided by 4 is going to give us 408. Oh, okay. Now I can read that as 408 thousands. So I'm going to write that out over here. 408 thousandths. Okay, so what that tells me is I'm going to translate that into 408 with the 8 in the thousandths column. And there you go. So those are your choices. Good luck with this.